So we got number 4, this is the gorilla problem. And we know that on each of those cables there's a force of tension Y1, and there's a force of tension X1. And the other cable would have the same thing. I'm just not drawing them to consolidate space.
Yeah, sounds right.
When I beg you to start with a sum of forces, it becomes real imperative. So force of tension, or forces on the X, we have, Ft x1, Ft x2. We know they're equal and opposite. They're equal to 0. We don't care. We set them aside. But here we have force of gravity down. We have force of tension y1, force of tension y2. And these two are equal. So really what we have is they sum to 0, and it's force of gravity and 2 times force of tension on the y. So we have to create an expression, of course, for, we said that's 30. So force of tension on the y is cosine. So negative f of g equals geez Louise, to f of ty, and f of ty is f of t cosine theta. So I have a feeling that your trig functions are a little bit misplaced somehow. And that gets you to your ability to solve for f of t. So that's where you want to have, just like we did expressions for Vx, Vy in motion, you want to make sure that you're creating expressions when your forces are divided for, force of tension on the x, force of tension on the y, and then go ahead and create the expressions using your trig functions.